Hello, everyone, and welcome to the Convo AI World podcast. I'm your host, Hermes Frangudes, Director of Developer Relations here at Agora. Joining me this week is Ben Weeks, Principal Architect. This is the first episode in a series that's going to be exploring everything voice-first conversational AI through honest conversations with practitioners, builders, infrastructure engineers, product strategists, people from the trenches providing actual insights on what it takes to build this best-in-class conversational AI experiences. So whether you're a developer, conversational AI enthusiast, or a business person trying to understand this world and navigate it, you've come to the right place. Without further ado, we'll jump into our first episode. What is conversational AI? And thanks again, Ben, for joining me this week.
Thanks, Hermes. Thanks for inviting me on to be your first guest in episode 1, and wish you all the best with this series. It's very exciting. I've got the 10 t-shirt on, which is Agora's open source framework where it stands for Transformative Extension Network, but for joining lots of different AI endpoints together in highest possible quality. And we've been colleagues together at Agora for quite a few years now.
Yeah, it's great to be doing this with you, Ben. We always have a good time, great conversation. So I'm excited for today's show. And I think to get it started off really simply for the viewers at home, for everyone kind of joining us, let's define what we mean by like voice first conversational AI and how that's really different from chat-based systems. So Ben, maybe in your words, if you want to take this one.
Yeah. So the way I look at it is that very much like talking to a human, you can talk to AI in 3 different modes, it's called. You've got chat, you've got voice, and you've got video or pictures. And while text and chat these days is probably the most prolific, voluminous, when you get into voice, that's where you have your more intimate experiences. And if you're ever in a video call, it's the voice that's the most important thing. If my voice starts to go in a video call, everyone's going to lose interest and start reaching for the door. But if the video freezes for a little bit or the text is a little bit late, doesn't really matter. As long as we've got continuous audio and our ears are really sensitive to that, then we're connected.
Yeah, the brain kind of picks it up. It'll let you drop a frame or let a freeze, but the audio interruption really kind of kills the flow, right? And
exactly.
And that's
and in
where
the old days
really
on analog phones, they used to play something called comfort noise so that you could actually feel that you were there even in silences to kind of create that feeling of connectivity.
That's really interesting. So getting back to voice first AI, and you brought up an interesting topic around like comfort noises and what they used to do to kind of improve the experience. Right now, what are some of the real world examples of voice-based agents you've seen? I remember you telling me something about last time you went out to dinner.
Yeah. So in terms of pure voice agents, these days, if you try and book a restaurant in the UK, I'm not sure what it's like in the US, but probably similar, you're always going to get through to a voice AI agent, and they actually sound really human. It takes you a while to actually realize because they introduce themselves with a name and everything, and they've got very, lifelike, emotional voices. Compared to the old days of ringing up your bank to try and do something over the phone, where most of the time it didn't understand you. And even if it did, it would just put you through a sort of a memory, sort of a flowchart IVR system.
Super clunky, right? You got to figure out which basket you fit in.
Exactly. If anything, it was just trying to get you to go online. That was the whole purpose of that. But now you really can just phone up. And because you're on your phone, it knows who you are. The identity of your phone number allows the system to be able to recognize you from making your booking before, so you can modify your booking. But yeah, certainly in the restaurant area, we're seeing a lot of pure voice AI services. But any sort of call center that you might be calling up is definitely going to be benefiting from the recent advances in all the different parts of the conversational voice pipeline.
Well, I'm so glad you brought up pipeline, because this is really an opportunity where we can talk about, like, let's define the tech stack. Let's break it down. What is the first piece of it, right? Like the speech to text, what's happening there? What is ASR, like noise cancellation, voice activity, the VAD? Like, let's dive into a little bit of that.
So the 3 main components of a conversational voice pipeline are the speech to text, or sometimes called ASR. They're sort of interchangeable, but they mean slightly different things. And that's where the computer gets to understand what you're saying, and that gets turned into text. The second part is then being able to take that text and come back with an answer. We've all played with ChatGPT online. You know what it's like. You send it some text, it comes back pretty quickly with a pretty decent answer. You can ask it to keep that limited to a certain number of words. and then those words can get turned back into voice again and spoken back to you. And that's what's known as a cascading pipeline. That's one sort of field of this. The other area is what gets called a real-time pipeline. They're both actually real-time.
So is that the voice-to-voice
Yeah.
pipeline?
OpenAI coined the phrase real time, even though the cascading pipeline I just described is actually just as fast. So it's also real time. But real time, as coined by OpenAI, and also Google Gemini does the same, actually takes in voice directly into the LLM and sends voice back out again. The idea being that it's even faster. But even though the speeds are similar, it does have other advantages in as much as the LLM can actually hear the emotion in your voice. It can comment on your pronunciation of certain words in the language tuition setup. And it's able to format the tone of the output of your voice to actually match the sentiment of what it's saying a little bit stronger.
Even though it's a bit of a black box system, it has its advantages in taking the audio in first and dealing directly with it versus the cascading that's more
in theory. But even with cascading, when the speech to text happens, you can put in, or some speech to text engines will put in metadata to describe how the person spoke it, like was it sad, was it energetic, those types of things. And also when you send the text from the LLM output to the text to speech engine, you can include speech markup to tell it which bits should be pronounced in certain ways, and again control the emotion in your voice that comes out at the end. So actually, they're pretty similar, even though no one really knows exactly unless you work at OpenAI or Google Gemini. I think the implementation behind the scenes of their real-time voice-to-voice models is kind of around a cascaded model anyway. Although interestingly, when you look at the text coming out of OpenAI along with the voice, they often mismatch. So I might hear, "Hi, Ben, how are you?" But in the text, it's saying, "Hi, Dan, how are you?" So they're not perfectly in sync. It's like they're using two different systems to create the effect of a pure multimodal LLM. And by multimodal, we mean capable of speaking text, voice, and video all at the same time.
so the text is more of like an approximation as to what it said versus like a
They're
word for
basically
word.
applying speech to text on what goes in and out of the LLM separately to what the voice LLM is actually doing.
Very
And they're
interesting.
not perfectly in sync, which is a bit misleading at times. At
Awesome.
least with a cascading pipeline, you know that what you see in the text is 100% going to match what was said and what it thinks you said and what it's trying to say back.
Yeah, I think that transparency is pretty key though, right? Because the black box method has some of those limitations. You don't get the same access to that information for auditing purposes and setup and in that sense. But you also have kind of like limited control, right? You have to use whatever function tools that they have put in place there and that sort of thing versus cascading. I feel like
So with cascading, you can mix and match your providers. Like my hottest pipeline right now for the language learning use case is to use 11 labs for speech to text, even though they're known for text to speech, but their new speech to text is really good for multilingual. Then into Grok for your LLM, probably Llama 70 billion model, which is super fast. It's on specialist hardware, so it replies really quickly. And then into OpenAI's text to speech, which is able to mix languages and has really good emotion built in, different accents, dialects. It's really quite good at telling jokes. It can whisper, it can do this type of thing.
that's a pretty interesting pipeline, right? Like
Yeah.
completely from left field in terms of what each of those providers is really known for, right? You would think OpenAI would be maybe more the
The
LLM
LLM.
of choice
Yeah.
and the LLM.
Exactly. It's almost back to front, isn't it? It's interesting.
That's super cool though, and I'm gonna have to try that out for my next project.
Yeah. That's my language learning. For my companion sort of, semi-dating where you maybe want the LLM to be able to not be restricted to not being able to, swear or talk a bit more in an adult fashion, then you can use XAI for the LLM side of it. And that's really quite good at providing conversation. And then you can get different voices depending if you want to clone someone's voice.
So like using your own voice or
Yeah, well,
having a
if you're
specific speaker,
making
right?
yeah, if you're making an avatar of someone famous, perhaps you might want to clone their voice and provide the exact look and feel of that person. And then on speech to text, I think DeepGram is generally considered pretty fast, and they're getting into lots of different languages right now as well. But one of the beauties of a platform like 10 is we're kind of agnostic to all your different speech to text, LLM and text to speech. and even your avatars, which is the video element of a conversational AI agent. And you can mix and match depending on your need. And different verticals and different regions of the world tend to have different advantages with different providers, depending on what you're building.
Before we get too far into the infrastructure, I want to back it up 2 steps because you brought up a very interesting topic that I do want to touch upon, and that's the virtual avatars, right? So these are they're the other dimension, right? We spoke about text, voice, and now the visual element of the conversation. It can kind of get a better understanding of the context in that sense,
Yeah.
right?
And like there was the whole uncanny valley thing a few years ago, but various avatar providers are getting really good now with video based avatars, which look just as good as real humans. And that is the video element of this. So in certain use cases, again, like learning a language, it's really important to see the mouth, when you're learning, when you're getting used to sounds, or if you're having a companionship or maybe mental health, you're more likely to open up if you've got that face, the visual contact, and all the other emotions that get triggered in your brain by having someone else's face in front of you, in addition to the audio, is really important.
It adds another layer to the emotional connection, right? Being able to
Yeah,
visualize, not just hear it. So that
exactly.
multi sense.
If I couldn't see you now, that would be, less than half as good. I mean, the voice is important, as we said, but the video is the cherry on the cake.
That's a great way to put it. Now let's kind of take that jump forward into more of the infrastructure side of it, right?
Or maybe I should just quickly touch on some of the different technologies involved in providing really high quality conversational voice, such
Yeah.
as your AI for voice activity detection, because it's really important with that cascading model and even with the voice to voice to know when the agent, the AI, should reply. Is it when I stop talking for 300 milliseconds? Is it when I've actually said something which implies that I should reply? And maybe I've just I'm thinking about something and it should allow me the time to respond.
So that's more than just VAD. That's like turn detection as well, right?
Yeah, it's voiced, it's both of those wrapped into one, and using a lot of AI to predict when the right time to reply is.
And I think 10 just released some stuff for that, right? They just released a new open source model on turn detection and VAD.
Yeah, exactly. And without that, it's not a very good experience. Like if the agent replies too quickly, or if someone else, like if I got my radio or TV on and that triggers a response, then that really breaks down quite quickly in terms of a natural conversation. And that's actually trying to talk to an AI agent in a public place right now is definitely, well, this time last year it was almost impossible. And yeah, it's getting, that's a big area of research at the moment, and making it worthwhile.
So in terms of maybe like the infrastructure side of things, what would you say are the biggest pain points in developing a Convo AI voice agent at scale?
Yeah, typically you're going to have a server running somewhere, but you want your users to be anywhere in the world. And to be able to transmit that voice reliably and quickly with the lowest amount of latency or lag is a real massive challenge. And again, that's where Agora steps in with its overlay network. I mean, Agora's been doing voice and video between real humans for like 10 years now. So being able to take all of those skills and
At a global scale, right? Like it
yeah,
doesn't matter whether you're next to each other or hundreds of thousands of miles away, you're getting the same low latency streams everywhere.
yeah. And the algorithms for echo cancellation, noise reduction, they're all completely applicable to this as well.
Yeah, because at the end of the day, the AI has to hear what you say, right? Like if you lose a packet, that's probably some of the most important packets. Like if it's person to person, it's a different thing. My brain can piece together kind of what you're saying. But if the
Yeah.
LLM doesn't get it, it really messes up the message and goes completely
And,
wrong
and
direction.
90, in fact, nearly all AI service providers, so all your speech to text, your LLMs, your text to speech, they're all using WebSockets, which is a TCP based technology. So the further away you move from America, effectively, where they're all being hosted, the bigger the latency you're going to have, and the more packet loss you're going to have as you get further away on the public internet.
Yeah, because web sockets aren't really made for that last mile, right? Like you have to have a really strong connection, and under optimal conditions, WebSockets are great, but
Yeah.
it's real life. Let's be real.
So that's where UDP, which is basically sending packets without waiting for them to be acknowledged, and automatically retransmitting them if they become late or lost, is much better for video calling. And again, that's kind of Agora's bread and butter from doing video conferencing, voice to voice and video to video between real humans.
And it's interesting because Agora supports up to what, like 60% packet loss while still being able to put through a signal that the person on the other side can understand, right? So in
Yeah.
terms of the encoding, maybe it'll drop from stereo to mono. Yeah.
In a two-person human call where I might be here and you could be in India, if you've got packet loss on your downlink, typically every other provider that I know would get the publisher to resend those packets. Whereas with Agora having points of presence all around the world, you can get them resent just from your India access point without me in London having to resend them again. Or a lot of other networks tend to use a single node or conferencing server. So we'd either be having a conferencing server in London or India, and one of us would have to be requesting from a long way. Even Google Meet uses a single conferencing server somewhere in the world for joining all the people together rather than multi points of presence.
That's interesting. So it's using like a single, almost like an SFO of sorts.
SFU, yes.
SFU. Yeah. So
Selective forwarding unit.
I'm flying out of SFO later tonight. So yeah, that I think that's a great breakdown of how the infrastructure side of it really matters. And in terms of frameworks, right? Like we're talking infrastructure frameworks, there's got to be some great hitters. We talked about 10. I know there's a couple other out there. Is there any ones that really like move the needle, and which ones are really there for
I
production and
think
ready to go?
the big ones are LiveKit. They've got an open source LiveKit agents and LiveKit Cloud. And then you've got Pipecat, which is kind of spun out of Daily, mainly using Daily's network for the voice and video. And then 10, which is Agora. And it's no sort of surprise or shock, really, that all three of those have come out of traditional online video conferencing technology because it's that UDP framework which really helps. I think the big difference to look at those platforms is both LiveKit and Pipecat are Python through and through, quite easy to learn and get up to speed with.
But that's a lot of overhead, isn't it? Like in terms of operational costs, you're going to have to run more powerful
Yeah,
machines.
from a runtime performance perspective, that's true. But in terms of developers, getting up to speed quickly with some examples is quite straightforward. Whereas the 10 framework from Agora is written in C. It's a bit of a steeper learning curve, but the end result gives you much more powerful, performant agents running on your servers. So it's more scalable. And I think Agora is all about scalability, really.
Yeah, scalability without compromise on flexibility, right?
Yeah. And even though there is a bit of a learning curve and not many people know C that well, it's quite complicated. These days with AI helping you to write code, you can just ask it to create you a 10 extension, ask Claude or whatever, show it the docs and the template code. You did some of that, didn't you?
Oh yeah, I made a little CLI tool that you could
Yeah.
describe the plugin that you wanted, and it would format it correctly and everything. But I
Yeah.
think the 10 team's also been doing a lot with their designer tool, that drag and drop, being able to like define the
Graph
plugin.
tool.
Yeah, the graph tool.
Yeah. I'm not sure about that personally.
I saw a nice little sneak preview. It's coming. It's going to be something cool. In terms of, so those are great frameworks. The 10 framework is open source, right? And you talked about how Pipecat has Pipecat Cloud, LiveKit has LiveKit agents on the hosted side of it. 10 is the base for Agora's conversational AI, right? And our conversational AI engine is that best in class VAD, noise cancellation, and allows you to bring your own LLM and TTS to the equation, right? So in that cascading model in Convo AI, I want to pick your brain on like where you see a lot of the strength in that, and how that's kind of a better model to approach than maybe some of the other hosted frameworks.
You mean cascading versus real time or
No,
10?
like our version of the cascading in Convoy AI engine, and really the flexibility that it gives developers on their ability to launch conversational AI engines with that best in class SDRTM network.
So I think the main sort of advantages would be that the extensions will ultimately be running in a C environment, so they'll be faster when you publish them into Convo AI Cloud. And then you've got Agora's SDRTN real-time network that we spoke about, which is multi-points of presence rather than everyone connecting to a single point for a server. And then the AI for interruptions, voice activity detection, echo cancellation, and noise reduction. All of those are sort of best in class. And I think a lot of the other services are generally WebRTC wrappers. So they're all using the same kind of RTC technology. And while Agora does use WebRTC in the web browser, we also have native SDKs for every platform as well. And our technology for actually calculating the bitrate, the available bandwidth between the server and the web browser is custom to us. So our we call it VOS Web internally, but it's a much more advanced way of detecting whether it's line packet loss or congestion packet loss on the downlink, and then knowing how to deal with that either by resending packets or by reducing the bitrate. And with voice, you can't, some of this stuff isn't quite as important because voice is low bitrate and you have forward error correction where you just retransmit the packets anyway. They're little. But when you get into video with avatars, it's much more powerful to have the Agora architecture where you can accurately know what the downlink bandwidth is and address the downlink connection by either increasing the bit rate or reducing it, depending if it's line or congestion packet loss. And we've also got access to advanced AV1 encoders, which are more efficient than the standard ones. So there's a lot.
They're like what, 30% more efficient or something?
Yeah, the
Massive like
same with our H.264 as well. We've really optimized the encoder so we can do that at higher scale. So we can do 1080p 30 frames per second at 30% less than the benchmarks. So again, I mean, when you're just like building a proof of concept science project, maybe you would find it quicker to do it in a pure Python thing taking off the shelf. But if you're thinking about delivering a service to thousands of customers concurrently, then you really need to be thinking about looking at
that performance and the scalability of it. So speaking of delivering to customers, right? Like something that you really need to think about is the idea of like function calling and tools and RAG, right? So let's demystify these things because I think you have like a really cool perspective and would love to have people hear it.
Okay, so we all know that when you send it's called a prompt into ChatGPT, that's a big load of text and you'll get back a response. And our RAG, which stands for Retrieval Augmented Generation, is basically the ability to pull some information from a database, just a regular database or a vector database, to give the LLM more information about that topic. So let's say that I was an end user asking something about I don't know, studying to become a hairdresser or something that maybe my LLM didn't know much about, like the exams around it, because it hadn't been trained on that. It would be possible to pull information from a specialist database about that and include that in the prompt. So when I'm asking a question about what do I need to prepare for my finals of hairdressing, in goes the syllabus along with my question, and the LLM can then provide a more accurate answer than just relying on whatever it was trained on 2 years ago. So yeah, RAG, for whatever it is just providing extra information in that prompt. And then function calling is the ability for the LLM to trigger an event. And you can do that quite easily. I mean, lots of different ways. Like you could just say to the LLM, if you want your avatar to shake its head, include some angle brackets head shake. And then instead of playing that out with the TTS, the client would just send a message to the avatar to get it to shake its head.
So that you would kind of extract that extra metadata out and then process from there.
But by using functions or tools, it's a much more standard way of doing that, such that it doesn't get mixed up between what should be spoken and what should be acted upon. And even though tools are fairly new and they don't work very well in anything really that's been around for longer than a year or so, like all the old Llama stuff and the LLMs out there, they're not completely standard and compliant with the latest tools specification. But OpenAI is pretty good. DeepSeek seems to be pretty good for most of the models. But again, you can avoid some of the models being behind by just asking it to include keywords instead in your output. But with a voice-to-voice model, the real-time ones, you really need to use functions there because you don't want the text coming out to contain anything other than what should be spoken, because that's how they work. They're voice-to-voice.
Speaking of voice-to-voice, it reminds me of something we were talking about the other day, and you brought up a very interesting topic around how the longer you talk to the voice-to-voice model, kind of worse it gets, right? Like,
yeah, that's a whole new subject, the pricing, right? The pricing of cascading versus voice-to-voice. Voice-to-voice is like 20 times more expensive to begin with. But when you start off, as you progress in a cascading conversation, every request into the LLM has to contain the history for the whole conversation. So after a few minutes, you're sending in a massive context window, which is the history of this conversation.
For the voice-to-voice, you mean, right?
Yeah, with cascading.
Cascading.
Cascading works with like a synchronous request into an LLM and a response out. That request will contain your RAG, it'll contain your function definitions or telling it to include certain things, and it will include the question or whatever.
So like your message history and then your prompt, right?
And every time you continue the conversation, the whole history of that conversation has to be included in it, which means that because you're paying per token, as the conversation goes on, it's getting exponentially more expensive with cascading.
But you can do stuff to reduce that, right? Like you could summarize some of the history and
You can, yeah, of course, you can do that type of thing. But if you want to have lots of detail in your history, if you're playing a game or you're doing some sort of role play, it's quite hard to summarize it without losing information. Whereas the voice-to-voice model, it's expensive to make each request, but it's a fixed price, and you don't have to keep sending the history because they're effectively maintaining the session in the server, which is probably why it's more expensive per request, but it doesn't grow exponentially in cost as the conversation progresses.
But doesn't the voice to voice kind of lose some of that original prompt? And
yeah, and it certainly does. I mean, if you build a language tutor commenting on your accent right now, your pronunciation with Google Gemini, first few sentences, it sticks to the program. And after a few sentences, it tends to start talking about something else entirely, or not even commenting on the words that you're mispronouncing. It loses the thread of the conversation quite quickly. And you're right, you can't keep updating the prompt. You only update the prompt at the beginning of a session with a voice-to-voice model.
versus the cascading, you can kind of adjust it every time it comes
yeah.
in, right?
And I read something recently that you get much more accuracy if you always put the actual prompt at the end of the history rather than the beginning of the history. I mean, silly, obvious, not so much obvious, but just like basic trial and error things that people have learned about LLMs and how to get them to be accurate over longer periods of conversation.
Brain is full of amazing little nuggets that you've passed through here. I don't know if you want to go into maybe like a demo. I think you've created something pretty cool, so we should probably show that off.
I've got a little demo of, is that visible? So in this demo, we're gonna have voice, video, and chat modes. Here we go. And this is using an avatar to sell a watch. It could be on a live shopping platform.
Welcome to my store. How you all doing? Let's get started here. This Patek Philippe Aquanaut 5167A is priced at $22,800. You're getting a real deal at 8% under retail. With its exceptional features and a potential value.
Is it stolen?
Rest assured, it is not stolen. The package comes complete with its certificate, authentication report, and all original documents, as well as boxes confirming. The Patek Philippe Aquanaut 5167A features a striking black checkerboard dial accentuated by the sleek steel case. The package also includes the signature black tropical rubber straps.
Does it have any scratches?
40.8mm steel case has only faint hairlines, adding character but not detracting from its beauty. The crystal remains flawless, ensuring clarity and elegance when you wear this timeless piece. This
Really
Patek
cool.
Philippe Aquanaut 5167A, priced attractively at $22,800.
I'd like to buy one. How soon can you ship it?
Great choice. Once payment clears, we'll arrange insured overnight shipping, ensuring it reaches you swiftly. The package includes a 3-day inspection period, giving you peace of mind.
Yes,
Shall we
please. Let me buy it and ship it.
Fantastic. Once you've completed the regular purchase process and payment is confirmed, we'll ship it overnight. You'll soon have this exceptional Patek Philippe Aquanaut on your wrist. Secure the deal now and enjoy. You're welcome. If you have any other questions, feel free to ask. Take care. If you ever need help, I'm here. Goodbye.
And there was a pause there. I didn't say anything on purpose, but the LLM actually continued. Because usually you think about an LLM, it's one request, one response. And actually that's what happens here. But when the state changed from talking to not talking, and the other person, the playing character, as he gets called, didn't say anything in that scenario, then it triggered another message to get the seller effectively to continue selling. So it's this idea that you can have a continuous live shopping channel, multiple people texting or typing. I mean, I allowed it to interrupt there, and perhaps you wouldn't want that. You'd always want the agent to complete what it's saying, but it just showed the multimodal, the ability to interrupt. And people will be able to sell to, lots of people simultaneously rather than just one person at a time.
It was super cool. And I think the ability to interrupt it both with speech and text was very interesting, right? Like it has that multimodal, and that's that cascading model, right? Like this is, you have full control over the pipeline and how that data is moving through.
Exactly, you're right. And no, you're totally right, because with the voice to voice, the thing just doesn't like to be left quiet. It'll just start talking on its own. You can't keep it quiet.
So you're going to have to constantly like interrupt it at that
Yeah.
point. Yeah. Which is a
Exactly.
weird experience. That's kind of everything that I have on my list of things I want to talk about for this episode and go through. Ben, I really want to thank you for joining us today, and for everyone watching and following.
It's been a great pleasure, Hermes. And if any of your future watchers want to get in touch to get help with any projects, I'm always excited to hear what people are building. So please reach out, and look forward to seeing what gets built in this space over the next year or so.
For sure. You can reach out directly through the main Agora accounts on LinkedIn, Twitter,
Yeah, LinkedIn's
YouTube,
good.
or you can find us on LinkedIn and Twitter. Cool. Thanks again, everyone, for watching. Thanks, Ben, for joining. I ask everyone, please like, subscribe, share this with anyone that you think would find value in our conversations, because we're really just trying to bring a lot of light into this space where most people are building, and there's a lot moving very fast. And we got to try and share this knowledge base so that everyone can be growing together, right? And I want to invite everyone to be on the lookout for our next episodes. We're going to be live streaming them as we record, and then releasing the final edited versions for everyone to consume and share. So that being said, we'll see you in the next one.